We have done two videos. We have done the lab setup and we have added a hard disk as our storage device for doing the POC of OpenStack Antelope, which will be which is an LVM backed. So in this video, what we will do is this is the screen from the last video where we created the uh, volume groups in the LVM using the disk that we had added on our controller node. So our controller node is also acting as our server node, we can say like that. Now, in this video, we will be installing the Packstack binary, and then we will be generating the answer file using the Packstack binary that we will be installing. So this is the steps that I am following from rdoproject.org. These are the steps. And here we can see install the Packstack binary. So we can run this command simply. Why? Because we already have if you do a DNF repo list, we already have the CRB repo and OpenStack Antelope repo, which was installed as part of our prerequisites. So, okay, let me just copy. Sudo is not required. We are already root, just in case. Make sure we are running this on the controller node, because from here we are going to initiate our OpenStack installation. Packstack, yes, it will install a lot of Ruby gem binaries. Of course, Puppet will be there, and these two in combination will help us to, uh, run the entire setup. Yes, the installation when we will start, it will take some time, but of course we can check the logs and see what is going at what point of time. So now we can see that Packstack is installed. If I do a Packstack minus H, probably, yeah. So this is what Packstack has to offer as command line arguments. See, there are so many things that is possible to do with Packstack. Yeah, here it is. So you can validate your answer file, and this is when we minus minus answer file is when we actually have generated an answer file and we want to execute the installation. Whatever is there in the answer file, all the arguments can also be given as a command line. All in one is a setup where we don't have, different nodes, and everything gets installed in one node. So your one node is the controller, same as Neutron and same as compute. So yes, if you have a big server, yes, you need a lot of RAM for that. However, we cannot test migration and stuff, so that's the reason if sometimes we need two compute nodes to perform migrations. You can also make your Neutron node as a compute node if you want to test the migration. So that depends on what underlying infrastructure we have. And we can also run this with minus minus debug option. When we run this, OpenStack will actually create some folders in /var/temp directory, and it does not delete it. And if we don't give minus minus debug option, it will automatically delete those folders. Just in case if there is any failure, if you want to troubleshoot it, this option is very useful, and this is from where uh, we need to make sure we make this enable always either in our answer file or we give it on the command line. So this is what we will do now, minus minus gen dash answer dash file and the file name. Okay, so okay, let's run that Packstack minus minus gen answer file. equal to, we can give any name that we want. I will give OpenStack answer file. Let me use camel case. Okay. Okay, so it has generated. It says parameter config neutron L2 agent. You have chosen OVN net neutron backend. Note that this backend does not support the VPN as a service plugin. Jenny will be used as the encapsulation method for tenant networks. I think based on what we have our base infrastructure, Packstack automatically decides and prepares this answer file, and that's why it chooses OVN, and then it gives a warning. This is just a warning if somebody wants to use VPN as a service. So Jenny will not be supporting that, and it's just giving a warning. Anyways, we will not be testing VPN as a service as part of this setup. As I have mentioned previously, our main motive here is to perform a successful installation and to be able to log into Horizon. Yes, the first login will always happen using the admin username and password because definitely we don't have any tenants or projects created or any other user created, and then we can make our hands more dirty playing around with different stuffs that OpenStack offers. Yeah. So if I open this file now, so there you go. Okay. So this is it's a big file actually, and we are going to modify this now. So as a prerequisite, OpenStack does a lot of SSH from the controller node towards the rest of the other nodes when it wants to push any config or perform some configuration modifications respectively. So because controller node is the node which is going to orchestrate the um, you can say configuration of services. So however, we can also do one more thing because we haven't done that step where we had to do a passwordless SSH login from our controller node to the rest of the other two nodes, one direction only from controller towards the compute or network. What I will do is I will simply just remove this, and when I will run the Packstack uh, installation command for OpenStack, it will ask me to put password only once, and then automatically it will generate the public key, and it will do a copy ID from my controller towards the rest of the servers, which is the compute node and the network node. Yes, we can also do upfront as far as we are aligned with these steps. We can also remove this line and it will ask to put the password. Default password to be used anywhere, overridden by password set for individual services of all users. Okay, it makes sense to use a default password, uh, and I don't mind this option. So I will just put okay, we are not going to see uh, like we will be focusing on the steps which are more mandatory for our setup to function correctly. So yeah, MariaDB, of course, we want a Maria database which will be using MySQL. My.cnf will be the conf file for that. Okay, we need Glance. This is the image service for OpenStack, and we need the Cinder. Of course, we need the block storage. We don't need Manila, which is the shared file system. Of course, we need Nova, Neutron, Horizon, and yeah, this is the object storage, Swift. And for Glance, we have created our object storage, which will be coming from Swift. Celometer is for metering, and we need the Notch services also for Celometer to work. I haven't installed, I haven't tested these parts. Yes, Sahara we don't need, it's for data processing. Yes, my main requirement is heat because after this, my OpenStack installation, I want to do infrastructure as a code testing with my provider being OpenStack and my infrastructure as a service tool being Terraform. So we don't need Trove. So guys, these are lots of services which is offered by OpenStack. And yes, it's huge actually. There is a container service, there is a database Trove service. Bare metal installation can also happen using Ironic. Uh, yeah, one of the prerequisites we can consider is NTP. However, when we check the steps from RDO, it's not mentioned anywhere here. Now, I'm just relying on the time which I have in my system actually. And when I did my installation for the first time, I just verified if my hardware clock was in sync in all of the system and which was correct. And this was never an issue for me during the setup, to be honest. So what I can confirm is without NTP, it works fine. I mean, at least during my first setup. Let's see now also. I hope it works fine during this setup also. This is important exclude servers. So this helps us. So it might be that when you run the Packstack, OpenStack installer might fail for it can be one reason, it can be many reasons. Now I want to share my experience where my setup was failed and it was failed and I decided to exclude I think it was Glance or some other service, I cannot recollect now, but unfortunately, I got an error again when I ran it because I was excluding that server where I was hosting the Glance, which is basically the controller, and it gave me that there is a dependency and you need that service to again be reinstalled. So I don't have a clear picture of how this is going to work. See, this is the option which I was saying. So debug mode has to be yes. So here, if you do this, yes, OpenStack will not delete the folders or the files that it creates, and it will dump all the logs in the debug um mode. So that's the log level that it will generate the logs into. Of course, this is the important part. We need to give the FQDN or the IP address. I'm preferring the IP addresses over FQDNs. I'm going to change this to my compute node IP and this to my neutron or network node. Yes, if somebody wants to test this with the vCenter hypervisor, we can also test this. Yes, I will be trying this option as well because I have my vCenter running on this ESXi that I have, and it's vCenter. I'm not sure. I installed 8 or 8 update 3 or something. So we will try that. So this option is for VMware, I guess. You can give the vCenter user, the vCenter password, the cluster name. Okay, this is the storage host that we need to give for block storage devices. It is, as I mentioned before, your block storage device could be anything. It could be an enterprise level of storage, which is an IBM storage or a NetApp or a Huawei storage or a Dell storage or an HP storage. Dell and HP is one and the same thing. So it could be any storage. So we need to give the IP address where your underlying storage is. For me, it's an LVM backed storage. I have a block device and it's created on this node itself, which is 136. We created in the part 2 video of this series. Well, we are not installing the Sahara, which is the data processing service, so this doesn't make sense. Repos, we don't have any repo. RDO testing, satellite. Yes, we can give the satellite username, password if it wants to get connected to the satellite during the setup. This is all satellite. Okay, the SSL certificates. We are just going to leave this default right now. SSL certificates, yes, and I'm not touching those. This is my canonical name for my common name for the certificate, which is controller. OpenStack will install your messaging queue as RabbitMQ, and yes, it is part of our controller nodes, and we are installing this on the controller node. We are not enabling the SSL. However, in production, yes, we have to enable. We need to have certificates signed using this certificate authority, and whatever inputs are mandatory for the certificates, the the the, the root change, the passphrase, etc., has to be provided as inputs here to use the certificate successfully in the OpenStack setup. MariaDB host, as we discussed, we are going to install. Of course, we need that, and it will be part of the controller. The username password, we are just going to leave default. Okay. OpenStack by default uses, I think, after, I'm not sure, Rocky version, maybe. It uses, by default, it uses for Fernet tokens for all the deployments. Region is the default. I'm not going to touch those settings. And Keystone API version is 3. This is important when we actually do an authentication using the command line OpenStack binary. Yes, we have to give this parameter. Keystone LDAP, yes, our LDAP is also same, it's controller. So 136 is correct. And Keystone, this is all the part of Keystone. I think after Keystone, we will be able to see Nova. Let's see, this is all Keystone. I'm going to leave this for default settings. You don't have to change anything here. Okay, glance. So we have the image service here. And this step is important, guys. So I'll just take the screen a little bit up and go up again. So the glance config glance backend, storage backend for the image service. So this we want Swift. Swift is our object storage, and we are leveraging object storage to be able to store glance images. As simple as that, we created second partition, if you remember, and we formatted that. Okay. It says the valid options are file or Swift. If you don't give any option here, it creates a loopback file actually, and it will not fail, but it will create it. So we leave the rest of the options. See, this is the option for Cinder actually. LVM, NFS, could have created an NFS if you're using vCenter. Of course, we all know VMDK. NetApp is there, SolidFire. So I'm going to use LVM because my device, we created an LVM device. Now we will ask OpenStack not to create the device for us or a volume group because we already created. And if you see this option, which I discussed in my part 2 video, where I created purposely the name of the volume group as Cinder volumes, so that we don't have to change here. If you give any other volume, or if your volume name is changed, kindly take that name and just remove this one and paste it here. The size doesn't matter because it is not going to create the volume. Instead, it is just going to use whatever size you have given to the volume group present over here. NFS, NetApp, it's not part of this setup, so we can kindly ignore. This is all for NetApp. Okay. Okay, storage pools. There are a lot of options actually. This is for Cinder. Okay. Ironic. This is okay. This is for Nova. Now, actually, these two parts are important when we do a provisioning in the data center. Okay. Now, it allows you to do an overcommitment of how much overcommitment you can perform for your virtual machine based on what physical RAM you have. If you give 1.0, it will disable the RAM overcommitment. Now, of course, it's part of virtualization, and we might need sometimes RAM overcommitment. However, it is advisable to study this a little bit and then perform uh, these changes, because you know that when you are touching the RAM and CPU, I mean, you're playing directly with the resources in the underlying hardware. So we'll just make this because I've tested this with 2.0. Valid options for migration. So this is TCP protocol is not encrypted, so it's an insecure protocol. It's okay for me as this is my lab. I'm going to use TCP. We can also use SSH, and it will do, of course, it will do a public key cryptography, and it will generate key pairs, and that's how it uses the authentication between nodes performing the migration. And okay, now it's a neutron, but I'm just looking for one more part where we need to give the file system for our object storage, which is missed, I guess. It should be there because we need to give that. Okay, this is in the volume. There should be a step. Uh, just let me check that part. Sender NetApp, sender NetApp. Okay. Solid fire. And this is Nova, so I think storage is finished above. Okay, let us continue first with Neutron, and then let us see in the sequence what comes. If we don't find, we go back up and we see. So now the name, this part, Neutron, is very critical, and if it is not configured correctly, most of the time it will fail here. Now, as we all know that, or we should be aware that OpenStack uses network namespaces, which is native to the Linux operating system, and there are different uh, ways which helps us to leverage that network namespaces. One is Linux Bridge, the other is Open vSwitch. For this setup, we will be using Open vSwitch. Of course, Open vSwitch has more advantages over Linux Bridge. Linux Bridge is limited to certain functionality, which Open vSwitch is not. Again, this applies same as of storage. If we are doing things in enterprise, we will be having our own, maybe an SDN or uh, other networking devices, and we need to plug in, bringing the agents of those specific networking devices to be able to integrate with our OpenStack setup. So there are plugins available. For example, if you're using VMware NSX, if you're using Cisco ACI as an SDN, so that integration has to happen. And still, though, the agents, L2 agents for Linux, sorry, Open vSwitch gets installed, and it does an integration to the SDN solutions being used in the enterprise. So now, if we, the thing what I had observed is, if you want to use this bridge name, which is BRX, the default name, this has to be present in our network node. So specify provider if you intend to use a provider network to handle the external traffic. So I'm going to use provider here. Metadata we are going to leave. Metering agent, yes. As we discussed earlier, we don't want to use VPN as a service. Neutron M2, okay, we will be using VXLAN and flat networks. So these are the network type drivers, okay, that points to loaded from the network ML2 type drivers namespace. So this is what the Neutron binary has to offer. So when we install OpenStack, it is installing a lot of binaries. So binary is something that is going to ask the operating system to perform a task, and as part of the binary, it gives us certain capabilities, and it gives us what we can use. So we can use local, flat, VLAN, GRE, VXLAN, Geneva. Again, now for the ordered list of network types to allocate as tenant networks, the local value is only useful for single box testing and provides no connectivity. So we will be putting here VXLAN because if you remember, we already have a subnet setup and an interface setup for VXLAN, which will be specifically used, when nodes, when the virtual machines in different nodes, they want to communicate with each other. ML2 mechanism driver, we will be using Open vSwitch as we discussed. Open vSwitch. Flat networks, we will leave this as default. And comma separated list of physical network VLAN minimum max, specifying, okay, we will be leaving that. So this is the tunnel ID range. Okay, I will be leaving this for default. Okay, this is the VNI range. Okay, network identifier for VXLAN, I guess, for tenant networks, like how we have a VLAN identifier. So the encapsulation that happens of a packet, it will be assigned an ID which will be taken from this pool, and the decapsulation happens when the packet is reached at the destination. Open vSwitch, the L2 agent. SRIOV, this is not the lab for testing that. Even I cannot test over here. Load balancer, no, I don't have any interface. We could have added an additional interface. Well, of course, we don't have here. So this is now bridge mappings for the OpenStack networking Open vSwitch plugin. Each tuple in the list must be the format physical network. So basically, we need to do, so it's a mapping. So first we created a provider bridge. The bridge needs to be mapped to an external network. Now this external network is down. Actually, we can give any name, but I just prefer the default, which external network, and the bridge name I'm going to change because as we are aware, we used a provider bridge previously. So this was a bridge mapping, and now it needs a bridge interface. So interface goes in the way like we need to give, so this bridge will be having uh, what is our interface in Neutron. Let us see that. This is my network node. If I do an IPA, see guys, this one, ENS224 should not be having an IP address. This is my bridge, which I am mapping to the, this is my interface. I'm mapping to my bridge, okay? And this will be part of my external network. So that's the reason provider ENS224. This OVS bridge compute, it is asking for the bridge in the compute. Yes, I will be creating a provider bridge also over here. And this is the external network which I was talking about. And the tunnel interface. So the tunnel interface we created, it will be ENS226. So we can just, 256. So we can say we have an uplink on the server. We have a switch. If we consider the VMware terminology, we have a distributed switch. Distributed switch gets connected to the physical uplinks, and the traffic goes outside. It depends on where the traffic is destined. Same way we have a bridge over here, and we are leveraging the networking as VXLAN backed switch or a bridge, and we do a mapping of our bridge, which is provider, to the physical interface on the server as well as the external network. So it's a mapping. So Neutron OVS tunnel subnet. Okay, this subnet list of subnets, for example, used for sending tunneling packets. To accept the tunneling packets, this is useful when adding existing nodes to exclude servers, because in this case, Packstack cannot modify the IP filtering. So I don't mind using the same what I have for the interface. We are going to leave the default port for VXLAN UDP 4789. Kindly make sure that if we want to use the IP tables, we have to allow the required ports. In my case, in my lab, I have stopped the firewall service, and this was part of the steps shown over here by RDO. And the first step, we disable the firewall D. So that's okay. Now these other steps are for OVN, okay, and as we know, we are going to use Open vSwitch, so we don't have to touch any of the OVN related configuration. And we just skip down. We come to this is the OVN tunnel subnet. Okay, we can ignore that also. Manila is the file share service. We are going to skip Manila. We are not testing that over here. Okay. Horizon SSL, okay, you can create that config Swift storage. Yes, so it was here actually. So Swift, we need to use the object storage. Yes, and for glance, we are going to leverage Swift, okay. And for Swift, if you remember, we have our partition created. If you do an lsblk, this is the partition that I want to use for Swift. So we just need to give the name, make sure the file system is created. So because if you see here, each entry must take the format, okay. Packstack does not create the file system. You must do this first, and that's the reason we had to do an MKFS or XFS. This is Swift zones, it's okay. We can simply ignore this, okay. This is heat, it's the orchestration or automation. Okay, we don't want to provision the demo. So what OpenStack will do is it will create a demo project for us where it will create subnet networks, routers, just as part of testing. To be honest, I don't want to create that. Demo floating range, you can give any CIDR network for your floating IP. So floating IP is the IP address which we will be using for accessing our servers once it is provisioned. So a project will have a network which is private to that, which is very private only for that specific project. And if you want to access those servers from the outside, outside means outside of that specific subnet, we have to use a floating IP. And this is the subnet that OpenStack will use for the floating IP. Demo allocation pools. Image name, okay, CirrOS is the minimum which we can do. QCOW2 will be the format. That's okay. But I think if you're doing demo as no, it will not pull this details and do the provisioning. If you do demo as yes, then only it will work on uh, these things. Notchy, Ceilometer, we will leave all the default like that. Redis, yes, it's on the controller. Kindly make sure of the ports again. IP tables has to be stopped. Otherwise, we need to have the list of all the ports and we need to open them as part of IP tables. SE Linux is also disabled. Sahara data processing, Magnum. Okay, we are not using any of these services. So we have created the answer file now. uh, at least with the mandatory parameters for our setup to function correctly. So the last step, I just make sure I put this file as a backup in /opt if we just want to make some changes and refer to our previous backup file. So yes, guys, this was the part 3 now. We have installed the Packstack and also we have generated our answer file. Once we generated our answer file, the main part comes where we have to, we can say, give the proper inputs to the answer file so Packstack can read those and perform the installation. So in the next video now, we will be seeing the installation, we will be running it and seeing the logs, how things go. Uh, I hope this video was informative and hope to see you in the next video. Thank you for watching.